Okay, today's video we're going to talk about logarithms, and basically we're just going to introduce them and get used to what's going on. So let's start out with the definition. We got log base a of x equals y, and then that means that we got a, whatever the base number is, the base of our exponent. Then we have to the y, and then equals x. So this is just the definition. I would suggest memorizing how to get from one to the other. So, and this is how you say it: log base a of x. Okay, so they happen to use logarithms. Well, they were originally invented so that before we had calculators, multiplication was a lot easier, because if you remember the properties of logs, we're actually going to get there in the future, but the property of logs is that instead of multiplying, you can add the numbers, which is a lot more attainable if you don't have a calculator than multiplying a bunch of numbers. So that's how they were originally invented, and you can see that it's related to this exponential function. Now we want to look at these for calculus reasons, because the exponential function, as we're going to discover in a couple lectures from now, is that the exponential function is one of the best functions ever in calculus, and we're going to figure out why. But for now, let's get used to what logarithms are. And to start us off, let's get an idea of what the graph looks like. So here we are, we're going to graph y equals, let's do log base 2 of x. And so we're just going to create our xy chart, and this time, since it's base 2, we're going to pick our numbers nicely. So for right off the bat, we're going to do 1, and then 2, and 4, basically multiples of 2, and even 1/2 and 1/4. So then we need to figure out what our y values are. So remember, we got y equals log base 2 of, the first one's 1, and so we have to apply the definition, and we get 2 to the y equals 1. So what is y in this case? Well, we get y equals 0. Okay, next one, y equals log base 2 of 2. We have our base number is 2. The thing on the other side of the equal sign is y, and then that equals whatever's inside the logarithm. And so that equals 2. And so, since our base numbers are the same, then we know our exponents have to be the same. So y equals 1 in this case. Now we continue on. I would say challenge yourself, maybe pause the video and challenge yourself and see if you get exactly what I'm getting. So we're really getting used to the definition here. Okay, now for the 1/2, so log base 2 of 1/2. To the y equals 1/2. We know we can write that as 2 to the negative 1, so we see that our base numbers are the same, so y equals negative 1. And then finally, y equals log base 2 of 1/4 implies 2 to the y equals 1/4, which is 2 to the negative 2. The exponents, the base numbers are the same, so the exponents have to be equal. And there we go. So you can see why I picked powers of 2. So now let's try to graph it, and I'm going to try to put this so that it's all on one screen. So if it's 1, we're at 0. If it's 2, we're up 1. If we're at 4, we go up 2. And if we're out 8, we go up 3. And then if we're 1/2, then we go down -1. And then if it's a quarter, then we go down to -2. And here, folks, is the graph of the logarithmic function. So we have y equals log base 2 of x. Now we could discuss a couple things with calculus. First of all, let's discuss what the domain is. So remember, the domain are the x's that work. So we see that the negative x's are never included, and the logarithm function is getting really, really close to 0, but it never touches. So here we go. We're going to have our domain is, well, it never touches 0, and then it goes out to infinity. Okay, now you can kind of see this for a couple different things. So basically, let's look at, so we'll do some calculus here. So x approaches 0 from the right of our log base 2 function. We see that that's going down to -infinity. Also, if we wanted to look at the limit as x goes to infinity of log base 2 of x, we see that it is infinity. Okay, so well, let's get used to some more logarithms now. Okay, so next we have the common logarithm. Okay, and that's going to be base 10. We have a base 10 number system as it is, and so we got y equals log base 10 of x. That's our common logarithm, and so we're going to write it as just log x. So whenever you see log without a base number, then there's an imaginary 10. And basically, the exponential form is 10 to the y equals x. Very nice. So we can see some things about log. So log of 1 equals y. We can figure out what that is. So it's 10 to the y equals 1. And we see that y has to equal 0 in that case. If we look at log of 10, we get 10 to the y equals 10 to the first power. So we get y equals 1. This is just from the definition. If we got log of 100 equals y, we got 10 to the y equals 100, which is 10 squared, and then that implies that y equals 2. And then we can continue on. So you can see why it's nice, and we have our base 10 system. So keep in mind, whenever you see log without a